So we are back. So I will spend no more than 5 minutes to cover what's been going on. If you guys have questions, feel free to put in the chat or actually email us on the side or even reach out to Craig over here. So like I said, there is an HL7 collaboration with OHDSI right now that's going on. If you go to the community call under March 2nd, you can see and read more about it here. We have several papers in the last 2 weeks that's gone through either to preprint or to actual publication. Also, there is a Pioneer Study-A-Thon or a Study-A-Thon that's going on right now. If you guys have an interest in that, it's still not too late to join. It's the Prostate Cancer Study-A-Thon. It started this Monday, but it goes until Friday. So if you want to sign up, you can actually come to the site here and join the Study-A-Thon that's going on right now. It's not too late to join, so feel free to go there. As I mentioned, we have a few more publications out there. So one is this one right here up with that Jenna, Peter, and Danny did, and it's really great if you ask me. It's like, can you trust a prediction model, right? I get asked that a lot. Even for someone who doesn't do a research, I get asked that a lot. How do you trust the prediction model? So here they talk about some of that, some of those insights. So if you really want to have a read, go ahead, click on it. You guys can have a read through that. This is us, of course. Now, Patrick is calling for participation in a vaccine adverse events for, I believe this is special interest characterization study. The packages are already out there, available on GitHub. So if you clicked on that link, you'll get here. But if you have an interest and would love to volunteer and participate in this particular study, reach out to Patrick. His email is here, but he's also on this call as well. So reach out to him and have a chat with him. The other thing I do want to call out is there were updates last week or this week from some of the working groups. We have the oncology, the psychiatry, the medical device, and the NLP working groups. They provided some updates on what their roadmap was for this year. The oncology one is a little bit too big to click on, but you can see what they kind of accomplished in 2022 and what they're going to accomplish in 2021. Same thing with the psychiatry working group. Like one of the things that they're trying to do is to deal with the vocabulary there. And then the NLP working group, what they're doing, as well as the medical device group, what they're doing. So feel free to check out the videos that are out there, as well as all the material and content that we have out there in the community call. But another thing to look forward to, again, if you guys are awesomely still awake at 1 a.m. your time, most of you guys, feel free to come to the next one on March 16th, where they're going to have a bunch of community presenters talking about advances in patient level prediction. Last but not least, there is a challenge in March that we would love for folks on this side to participate in, okay? And if you go to the general OHDSI channel, you will see this. And if Patrick, if you want to provide any more color to it than I can, basically it's a COVID visualization challenge, okay? We would love for the community to show us any type of visualization that you guys have with COVID-19. And, again, we're asking for submitting static images of any kind. So to help, us better understand COVID, but also it's just a challenge we want to put out there to get the community to participate in. And right now you can see there are some submissions already, but we would love to hear from the Asia Pacific side about some of the stuff they're doing and some of the images that you guys have on this side of the world. Okay. Any questions? Save it for the chat or save it for later. I will stop presenting and I'll turn it over to Ty.
Thanks, Mui. So should I share my screen?
If you wish to,
yeah.
Yes.
Yeah, cool. Can you see my screen now?
Yeah, we can see that.
Yep.
Just put it on slideshow, Ty. Oh, good.
Yeah, thank you. Sorry, I should be a bit better technologically, but my old age always comes through. All right. So hello, first of all, my name is Ty Stanford and I'm a statistician from UniSA, and my co-authors and myself present the process of mapping Australian specific medicine codes to the OMOP standardised vocabularies, which specifically are the Rxnorm Extension drug vocabs. So I thought I'd start with a disclaimer about who this might and might not be for. So the two kinds of people that might be of interest to is someone new to OHDSI and wanting to know more about the nitty-gritty, and or someone who is currently converting their data to the common data model and wants to compare notes or processes or tell me how wrong I'm doing everything. But who this definitely isn't for is an OHDSI veteran that's gone through these processes before. This will be a pretty boring talk for them. But of course, I can't claim this will be an interesting talk for the former people either. So we'll start with a bit of background. And I've listed two things you have to do to get your OHDSI CDM all set up, the common data model. And I've probably listed them in the wrong order. So I've said the first thing is convert your data source into the CDM pre-specified tables, and all the details to do that are up on the net. And on the right there, I've got a little picture of the clinical data tables. But what I'm focusing on today is converting native vocabularies. So these are called source codes in OHDSI nomenclature. And we need to translate those to their respective OHDSI standardized vocabularies, which I'll call standardized concepts. So once you've done those two things, you've basically got your OMOP CDM, but we're focusing on the translation of your source codes. So continuing the background, in our specific case, we have a 10% sample of our National Pharmaceutical Benefits Scheme data, which is where the government pays in large part for a lot of our medicines. So our US friends will probably not know anything about this, not to have a go at them or anything. And this work is just to outline the process that we undertook. So we're going to show you how well we got our coverage of transforming our source codes, which are our PBS item codes, to Rxnorm and Rxnorm Extension. I should say that I'm going to refer to Rxnorm and or Rxnorm Extension as kind of synonyms. I won't get into the details of the difference today. And the other aim is to keep the granularity of our drug details. So we don't want to lose any information when we go to the OMOP common data model, and we'll assess that at the end. And then quickly finishing off the preamble, the aim of this work was to document the process we take, describe the mapping coverage, and probably most importantly of all, is get some feedback on our process. There'll be a few old hands that will probably tell us a better ways to do things, and that would be really good. Okay, so I've got a little schematic here of our mapping process. So on the very left there, we start with our PBS data, which is our pharmaceutical benefit scheme, and the vocabulary we start with is PBS item codes. However, OHDSI doesn't know anything about PBS item codes, but it does know about AMT codes, which is Australian medical terminology. So what we have to do to start with is map PBS item codes to AMT codes, and then we can start talking to the standard concepts that exist in the OHDSI database. So helpfully, the PBS itself provides a mapping to AMT codes. So we map our PBS item codes AMT, and then we go looking in the OHDSI common data model with the pre-filled concept table and concept relationships table. So in that picture, you see we swoop down and we look inside the concept table to find our respective AMT codes. And then we look in the concept relationship table with the aim of turning AMT codes into Rxnorm codes. So the concept relationship table is a fantastic table that links these concepts. And then with linking going all correctly, we end up with our Rxnorm standardized concepts. So when we swoop back up to the top, you can see that I've colored things green and red. And so green is meant to show that we've successfully mapped to Rxnorm Extension standardized codes. And red is when we've missed these mappings. So we don't have a standardized concept ID through that process, which is inevitable. And the good news is most of the, as we'll see later, most of the codes do get mapped to standard concepts, but we need to manually map the red ones. So there's tutorials online which do a much better job than I will, but I thought I'd just give an example of the process I just outlined in that schematic. So say we have a 100 pack of 500 milligram paracetamol, which is what we call acetaminophen in Australia. I didn't say that right, but I'll try to get it right by the end. So I'll just step through the process of doing a single drug. Obviously, when you do this properly, you use SQL and all that business. So on the very left there, I've got that mapping schematic of the process roughly that we undertake, and I've stepped through that in this example. So we're starting with our paracetamol drug, and it's got a PBS item code of 1746X, which means nothing to anyone here or myself. And we need to move it to an AMT code, which is the second row down there. So we use that file supplied by the PBS, and we've got our MPP concept ID. So that's in the AMT vocabulary, so we can go into our OHDSI database and try to find its concept ID. So you can see in the bottom row, we've got that MPP ID and its corresponding concept ID. And you can see the vocabulary is AMT and its medicinal product pack. So continuing on with the example, we've now got the concept ID in AMT vocab. So we go into the concept relationship table, which is the top row there, and we look for the maps to relationship, and we're going from AMT to Rxnorm Extension. So at the very bottom there, we've got our concept ID from our standardized vocabulary, which is acetaminophen, 500 milligrams oral tablet box of 100. So we can confirm that's the same thing as the paracetamol we started off with. And importantly, the standard concept is S. So that should all work in our common data model. So that's the way we find the mappings when successful. However, there's plenty that won't be successful. So we use a fantastic tool available freely from OHDSI, and I believe Martin Schumi wrote this excellent little program. This is a way of manually mapping source codes to Rxnorm and Rxnorm Extension. So I've got an example there, and you can see in the top of that screenshot, that's a list of all the things we missed in the automatic mapping, and it's got the source codes, which are the PBS item codes. But of most importance is the description of what that source code represents. And Yasagi uses fuzzy string matching to do its best job at finding target concepts, which will be your standardized concepts in the OHDSI database. And we were able to do that reasonably successfully, but we'll get to that in the results section. So just before we get to the results section, I just thought this is an important consideration that you need to go through is, as mentioned before, there's certain granularity in the details about drugs that you need to consider. So what I've got there is a table that's roughly taken from the Wikipedia, and there's a link there at the bottom. And we've kind of listed what internally we use as a hierarchy of matching. So the higher up in that table you are, the more granularity the standard concept has. So of course we want to match with the most granularity and detail. And we go down that hierarchy when we're manually matching sort of to get the most detail. All right, so results. So the results are going to take two little looks at the data. Probably what you're most interested in is the mapping coverage. But the first thing we're looking at when we're doing manual mapping, you're more likely than not in your little group that's doing your research or whatever application you've got to have more than one person doing the manual mapping. So it's important to do a little bit of inter-rater reliability. So I put together this little graph to see how we went. So on the x-axis, we have 3 different people, and one of them may or may not be me. And then on the y-axis is a whole bunch of PBS item codes that weren't automatically mapped. And then the tiles within that graph are the concept IDs that each of those people mapped to in the OHDSI standardized vocabulary. So the color of the tiles has to do with the concept class, so the sub-categorization of the Rxnorm concept ID. And the color of those concept IDs is black if everyone was in agreement, and red if at least one person wasn't in agreement. So you can see there's pretty good agreement. This is early on in the piece while I was still working out what our procedures were. But in 35 of the 38 cases where there's at least 2 raters, there was agreement on the mapped concept code. The other thing I should note is 2 of us were non-pharmacists and 1 of us was a pharmacist. And when we looked at this in more detail, the pharmacist was right almost every time. Once we learned from her more about the process she used, we were doing much better. All right, so on to the results that probably matter most is looking at our automatic mappings and our manual mappings and how well that created coverage of our data set. So when we're converting to the OHDSI Common Data Model, we don't want to lose any data of our patient records. So here in this table, you can see that OHDSI automatic mappings did an excellent job of doing basically all the heavy lifting, that we had about 75% coverage of our source codes. But probably more importantly is the patient records was 95%. So I would claim that's really excellent coverage. And then when we did our manual mapping in Yasagi, that did a good job of sort of cleaning up around the edges. And in the end, we're able to get over 99% coverage of the patient records and 85% of the source codes. And given a lot of the source codes can be historical or pretty obscure things, 85% was an excellent result. So looking at our mappings and breaking down the source codes, we're looking here at the standard concepts, but their subcategorization. And you can see a lot of detail was kept, so we're actually quite happy with that. For the sake of time, I'll just keep moving, but vast majority of match concepts were very specific with dose, form, quantity, and strength. And of course, this is an ongoing process, an iterative process. We just had to focus our energies on what was most important to us at the time, but these are the item codes that weren't mapped, categorized by their ATC code. So most of the missed ones were LO1, LO2, LO3, and LO4, which are likely to be cancer medications and things like that, which are drug classes that we weren't particularly focused on, but of course, we'll keep working on that. All right, so wrapping this up, to reiterate, we successfully mapped 85% of Australian specific codes, which accounted for over 99% of medicines dispensed. And the missed codes that we missed are likely for rare diseases, but as I said, we're working on processes to keep assessing those and chucking them in our common data model. And if you have PBS data, hopefully of use to you is we'll put up these manual mappings up for anyone to grab, and that will be thanks to the transformational data collaboration, and it'll be on the web sometime soon. All right, thank you for your time.
Awesome, thank you, Ty. We have a couple of minutes. We can take a question or two. Anybody have a question for Ty?
Hi, it's Ezra Fass here. I have kind of a
Hi.
I have kind of a rookie question, or maybe a dumb question, but what is there something that determines why Rxnorm is the standard, or I mean, is that just the industry standard, or why is that amongst the the set of codes is that the target?
Can I deflect that to you, Lloyd?
Yeah, let me clarify. That is not a rookie question, nor is that a dumb or stupid question, because everybody asks that question. Okay. So I don't have the history to it. So you see how you passed it to me, Ty? I'm gonna let's walk that way a little bit to the east of me and walk over to Patrick. So Patrick, do you have the history of why you guys picked Rxnorm?
The history here is that when we were starting, we were looking for vocabularies that were broadly representative of all of the clinical concepts across each of the domains. And at the time when we started to look at drugs and we looked at various international standards that were available, Rxnorm was the vocabulary that seemed to provide the greatest level of granularity and the greatest level of coverage of drugs relative to alternatives that were out there. So, for example, other things that are also contained in the OHDSI vocabulary include things like the ATC drug vocabulary, which is popularized in Europe and is used in some Asia Pacific regional databases. But ATC only goes down to the level of granularity of a given ingredient, and we didn't want to have information loss at the level of fidelity that Ty presented in terms of having information about dose and formulation and pack size. What's actually turned out to be, I think, actually I'd say was the right choice at the time and still would be the right choice, like starting with Rxnorm, has actually resulted in us having a pretty major explosion. What Ty presented also was this notion of Rxnorm Extension, and that's actually something built by the OHDSI community to cover the gaps that Rxnorm has. And if you look at it purely on quantity, Rxnorm Extension is 3 times bigger than Rxnorm itself. So we've ended up taking on a pretty massive effort to try to make sure that we have something that can actually serve as an international standard. And so even though Rxnorm was a good standard to start with, we recognize that it itself had some deficiencies that we're trying to kind of fill in. But one other commentary that I think is actually important here is it doesn't actually matter which vocabulary is the standard. All that matters is that as a community, we agree that there are some things that are standard and some things that are not, and we agree to the principle that we should try to get to a standard. And so from that perspective, we really are trying to avoid having people think the standard is Rxnorm, and instead to think the community's agreed on some standard. It might not be good. It might not be the best option. There could be something better. But regardless, we just have to agree that we're all using the metric system, because whether it's right or wrong, as long as we're measuring things the same way, we can actually make progress together. And that's really the kind of the spirit that's driving this.
Yeah, thank you. Thanks for the explanation. Appreciate it.
Wonderful question. Great question.
Yeah.
I am actually going to, because I'm looking at time, I'm going to turn this over to Jason now. If any of you guys have any other questions for Ty, feel free to put it in the chat and Ty can answer it there. All right. Jason?
Hi, can you hear me, Mui?
Yes, perfectly well.
Okay, I'm gonna share my screen.